Now that you've seen a few videos talking about sort of the differences between nuclear fission and nuclear fusion and what those words mean, I just wanted to take a second and go through some of the math that maybe wasn't covered quite as clearly. So the first thing I want you to notice, you should easily identify this as being a nuclear fission reaction because we're taking something that's larger and using that to create these smaller atoms. If it had been nuclear fusion, it would have been multiple smaller atoms coming together to create a larger atom. So, first thing I want to point out, you may not see this one right here in the middle all the time, where it talks about uranium-236. That is just easy to leave off because it doesn't stay in that form for very long. But for our purposes here, I'm going to leave that here so I can show you how that math checks out. So you'll remember in the videos, in both videos you started with uranium-235 that is being hit with a neutron. So real quick, that mass number, we have 235 for uranium. We add 1 for our mass number from the neutron because remember that our mass number is protons plus neutrons. We're not adding on any protons, but we are adding that 1 for the neutron. And that gives you 236. The atomic number right there, that number of protons was 92, plus 0. If we're adding just a neutron, it doesn't have any protons, it's just a neutron. So we don't add anything to that, so it's 92. Notice that these numbers right here are exactly what you get when you get uranium-236. So that's perfect and checks out. The next thing we're going to take a look at, when you divide that uranium-236, you get a couple of things going on. You get a barium atom, a krypton atom, and then notice you get 3 more neutrons. Remember how they talked about how that causes a chain reaction? Each of those neutrons can go on to hit another uranium-235. So we're going to add all these together to make sure it also checks out. So for our mass numbers, 141 from that barium, plus 92 from the krypton, plus 3 times 1. It's important you remember there's 3 of those neutrons there, so we do have to add 3. When you plug that into the calculator, you'll get 141 plus 92 plus 3, and it is 236. So notice we did not lose anything from that mass of that uranium-236. It's still there. Then we're going to look at those atomic numbers to get our number of protons, and it should also be the same. So 56 from our barium, plus 36 from the krypton, plus 3 times 0, which of course will be nothing. So basically you're just adding 56 plus 36, and that checks out. It is also 92, which again, same thing that we get right here on the uranium-236. So keep this in mind. If you're writing a nuclear fission or fission or fusion reaction, those numbers do have to check out. If they don't add up, then you're losing protons or neutrons somewhere, and that just doesn't make sense mathematically. So keep track of this. When you are answering your own questions, you'll want to keep this in mind.